Welcome back. Today I'm going to be going over this SAT line question. And once again, thanks to Anico.ai for providing this specific question in their free resources tab. But before I dive into the explanation, please give it a try yourself. Okay, so here we're given two lines, P and Q, which are perpendicular to each other, and they intersect at the point -1, 4. Line P has equation, whatever that is, where K is a constant. Which of these points here lies on line Q? So I'm going to show you both ways, right, on Desmos and the more algebraic way, but I'll do that one first. So first of all, right, look at what we're given. We're given that the equation of line P is this, right? And let's just go back to basic slope for a second, right? If you remember this, right, y equals mx plus b, well, that is a representation of a linear equation, right? Where m is a slope and b is the intercept, right? This is called the slope-intercept form. And if you notice, well, this is very similar, right? The equation given, right? So let's write that equation down, right? If you have y equals kx plus 4 plus k, well, what is the slope of this line, right? If you see the x term, well, the slope is going to be k, right? So the slope of this line is k. And the intercept is 4 plus k, but we're not going to really worry about that right now. So now let's look at this, right? So this is line P, right? So I'm just going to write line P. They tell us that line Q is perpendicular to line P, right? So this is where my title comes from, right? We're given the equation of one line, we're given the intersection point, and we know that it's perpendicular to another line. So therefore, I'm going to chase the line, right? I'm going to try to find the equation of line Q here, right? So in this case, right, because line Q is perpendicular, well, remember that perpendicular lines have opposite and reciprocal slopes. So this is going to be -1 over k, right? And what that means is, well, if you write the slope-intercept form again, right, of line Q, you get y equals, right, mx plus b. You know m is the slope. In this case, that's -1 over kx. And plus b. We don't know what b is right now, right? But we're going to find that out, right? So what else are we told? We're told that both of these lines intersect at the point -1, 4, right? Now just think about that for a second, right? If you have one line here, and if you have a perpendicular line, right? And they intersect at this point. What does that mean? Well, that means that that red point there, right? It's not only the solution for this black equation, for the linear equation of this black line, but it's also one for this green one, right? Because the point lies on both of these lines, right? Because both of them intersect at that point. So with that similar logic, well, first of all, we know what the point is, right? That point is -1, 4. So here we have -1, 4, right? And we know that that has to be a solution to this equation because that point lies on that perpendicular line too, right? So what you do is you plug in the x and y here into that equation to find the missing y-intercept. So in this case, let's do that. So you have this here becomes 4 equals -1 over k times -1 plus b. That becomes 4 equals 1 over k plus b. So we get that our intercept here is 4 minus 1 over k. So now that we know the intercept, let's rewrite the final equation of the line, which is y equals -1 over kx plus b, and the value of b we found earlier is that. And I'm going to write that in parentheses, but just so it's kind of easier to see, right, that that's the b part. So that, right, that equation there, well, guess what? We just found it, right? That's the equation of line Q. So we have done our job now. We have chased that line. We have found the equation of the line. Now, let's look at the actual question. It asks us to find which one of these points lies on line Q, right? Once again, this is line Q. I'm going to bring that down here. So, well, if a point lies on a line, right, once again, this goes back to what I just explained. That means that point has to be a solution for that linear equation, right? So that means if you, for example, if you plug in answer choice A into the equation for line Q and it holds true, then that means it's on the line, right? So what I'm going to do is substitute each one of these points till I see that the equation holds true. So let's look at A first, right? So here the value of y is 7, so you do 7 equals -1 over k times x, the value of x is this, so you do -1 over k times this, right? And then, right, of course, you do plus 4 times, plus 4 minus 1 over k, right? And let's see if this equation holds true. Well, what does this part become? That becomes 1 over k, right? This becomes -3, and then plus 4 minus 1 over k, right? Because you're adding this, that simplifies to 1, right? Because these cancel out. Well, 1 is not equal to 7, right? So there's 4, our answer choice is not A. Alright, let's go on to answer choice B. But before I go on to that answer choice, actually, I'm going to do something here. And I'm going to rewrite this as -1 over k x plus 1 plus 4. You don't have to do this. I'm just doing it because I see that there's two -1 over k's involved. And when you're plugging stuff in, it's nice to kind of have lesser terms in your answer, right? Or in your equation, right? So that's why I grouped everything here, right? Or I factored that -1 over k out. It will make substitution easier. So let's go on to B, right? We have that point. So that's 1 equals -1 over k x plus 1. So that's -1 minus 3k plus 1 plus 4. This part here, that's -3k, right? If you multiply that, you get 3. And then, of course, the plus 4 gives you 7. Of course, 1 and 7, they're not equal, so answer choice B is not the right answer. And now let's look at answer choice C. So we have, once again, 1 equals -1 over k, -1 plus 3k, right? And then plus 4, right? Oh yeah, we have to add the plus 1 here, right? This part here becomes 3k, this becomes -3, you have to add the 4, that becomes 1. And now you see that these match, right? That 1 here equals that 1 here. The equation holds true. So therefore, we know answer choice C is going to be our answer. So just to kind of recap, right? Your first step is to chase the line, right? Find the equation of the line given based off what you know, right? So here you know the point and you know that there's a perpendicular relationship between the two lines. Once you find that equation of the line, right, which we did, we found the equation of line Q. If you're trying to determine if a point lies on the line, we'll just substitute each point in and see if the equation holds true, right? Because for a point to lie on a linear equation, right, or a linear function, right, it has to what do you call it? It has to hold the equation value true, right? The equation has to be true. right? If you plug these points in to the equation. So hopefully that makes sense. But now I'm going to show you another way of doing this using Desmos. So now, right, let's say you're doing this problem and you're at this step, right? You found the equation of line Q. So what I would actually do is type that equation into Desmos. So yeah, y equals, and I'm going to use this one actually, the first one. So negative 1 over kx plus 4 minus 1 over k, and at the side. So now we have that line, right? Now, what do we do now? Well, we plug each one of these points in and see which one always lies on this green line here, right? Because that's what the question is asking. So if you plugged in, for example, answer choice A, right? Well, what you would see is that that black point, it only lies on that line. And actually, it doesn't quite lie on that line at every single moment, right? Every single value of k. So that's not an answer choice. Now, if you look at C, for example, which is supposed to be our correct answer from the other method that I used, well, you'll see that this point, right, no matter what the value of k is, it always lies on that line, right? So again, it always lies on that line. So that's how you know answer choice C is our correct answer. So yeah, that's kind of one way you can use Desmos to approach this problem, or if if you're trying to check your answer, if you do have some time left. But hopefully, that made sense. If it didn't, please leave any questions you have down in the comments. Make sure you click that subscribe and hit that like button. And we post videos here daily to help you on your SAT and ACT prep. So if you want to be notified when a video comes out, just hit that notification bell. And yeah, I'll see you next time.